Here we have the mean value theorem, which you can think of as the average slope across a closed interval for a function that must be continuous on the closed interval and differentiable on the open interval, since you don't need to take derivatives on the endpoints. So here's an example of a function from the closed interval from a to b. If we take the average slope from a to b, I'm going to go ahead and draw the line in green. Think of the slope of that line as your average rate of change. Now, the mean value theorem asks you to consider this. There's got to be a point somewhere in that interval where the tangent line has the exact same slope. So if I draw a point somewhere in that interval that would have a tangent line parallel, meaning it has the same slope, the location of that would be at some number c, which is in that open interval from a to b, where the slope of the instantaneous rate of change is the exact same thing as the slope of the average rate of change. Let's take a look at an example. Here we have a function defined on the closed interval from 0 to 4. However, we have a problem with this one. We might not be able to use the mean value theorem here because this function is discontinuous at x equals 2. In fact, you have a vertical asymptote at x equals 2, and that is within that closed interval from 0 to 4. So that function is going to approach infinity somewhere in the middle of that interval, and it won't make sense to consider an average slope from the two endpoints, since the slope's going to approach infinity at some point. So that means the mean value theorem does not apply. It's really important to consider those conditions before you can draw the conclusions of a theorem like this, since the conclusions would not make sense. You must satisfy the conditions. Let's take a look at another example here. Here we're going to look for other values of c that satisfy the mean value theorem on the closed interval if it applies. Same function here, so the only discontinuity is the x value of 2, but notice 2 is not within this closed interval, so the function is continuous from 3 to 6. We have no other discontinuity within that closed interval. So we're going to start by finding the average rate of change, which is the average slope, and the setup goes like f of 6 minus f of 3 over 6 minus 3. F of 6, I'm going to plug in 6 here and get 2 times 6 over 6 minus 2, minus plug in the 3, and keep this all over 6 minus 3, which is 3. And the first fraction is 12 divided by 4, which is 3. Second fraction is 6 divided by 1, which is 6. And this becomes negative 3 divided by 3, which is negative 1. Now, the mean value theorem wants us to look for a location where the derivative at a number is equal to that slope. The slope of the instantaneous rate of change at one location c is equal to the average slope of negative 1. To explore this further, we're going to start by taking the derivative of the function f. But instead of writing f prime of x, I'm going to change it to f prime of c. I'm just going to switch the variables up to make sense of what this value of c is. So the derivative using quotient rule would be denominator. Instead of x minus 2, I'm going to write c minus 2, times derivative of the numerator. The derivative of 2x is 2, minus the numerator, I'm going to write as 2c instead of 2x, times the derivative of the denominator, which is just 1, all divided by denominator squared. I'm going to write that denominator as c minus 2 squared. Let's simplify this derivative. It becomes 2c minus 2c, which cancels out. Negative 2 times 2 is negative 4, all divided by c minus 2 squared. Mean value theorem has a set this derivative of c, with c as your variable, set that equal to that negative 1 that we found, that average slope. Let's solve this equation and see what we get. I'm going to multiply each side by c minus 2 squared. I'm also going to divide each side by negative 1. Square root each side, don't forget plus or minus. C minus 2 equals plus or minus 2. Add the 2. Solve for c. 2 minus 2 is 0, and 2 plus 2 is 4. And the only value within this interval that we can consider is the value of c, which is 4. 0 is not within that closed interval, so we cannot consider it. We only have the conditions satisfied on that closed interval from 3 to 6. So the only value of c here, where the slope of the instantaneous rate of change equals the average rate of change, is the value of 4.